Good morning and welcome to Thursday's Maths. So the last couple of days we've been looking at ratio and the idea that when you've got two quantities that are proportional to each other, if you multiply or divide one side, you've got to do the same thing to the other. So that's what we've been looking at with ratio. We're now going to use ratio. Today we're going to use ratio to look at maps and scales on a map to work out what a map would represent in real life. And then tomorrow we're going to have a look at scale but using shapes. Nice and easy, let's get started. Okay then, so first bit to start us off. We've got a nice map of Sandy Island and I want you to try and explain to me, what is this scale telling us? What does this scale actually mean? Well, hopefully you can see that each square here, each 1 centimetre square, because this is showing you that each square is 1 centimetre across, and if it's a square it'll be the same down. So 1 centimetre, 1 square is the same as 2 kilometres. I wonder if you could write that as a ratio. So we could write this like this. 1 centimetre is the same as 2 kilometres on this map. Okay, this scale tells us that for every 1 centimetre there is 2 kilometres. And we're going to use this to work out other questions. So make sure you've got this written down somewhere. First one then, I want you to have a go at estimating how wide is this island. So it's just an estimate. So work it out in squares and then what is that equivalent to in kilometres in this particular scaled example. Well, if I count across, there's 1, 2, 3, 4, 5, 6, 7, 8. There's about 8 squares. Now, it's only an estimate because some would be 8 and a bit, some would be maybe nearer to 9, but the bit I looked at was 8, and it's only an estimate, so it doesn't matter if we're not perfect. So first things first, I've got that ratio down of 1 centimetre. There's 1 centimetre for every 2 kilometres, okay? If we see 1 centimetre, it's representing 2 kilometres. But we've now got 8 centimetres or 8 squares. So what have we times this side by? We've times it by 8. So what are we going to times the other side by? We're going to times it by 8. 2 times 8 is 16. So that 8 centimetres is representing 16 kilometres. So we can estimate that the island is about 16 kilometres wide. Right then, question 2. How far is it from the treasure chest to the palm tree? And I want you to have this one as an accurate answer. This one doesn't need to be an estimate. So you've already got your scale ratio. You know that on this map, 1 centimetre represents 2 kilometres. So what would the answer be for how far from the treasure chest to the palm tree? Well, of course, our ratio is 1 to 2, but now I don't want to know what 1 centimetre is, I want to know what 2 centimetres is. So I've multiplied the left side by 2, so I times the right side by 2. So 2 centimetres is the same as 4 kilometres. And if I look at the scale along the bottom, I can see that that is correct. Well done. Next one then. How far is it from the palm tree to the tent? Right then, answer time. So here's my original ratio, 1 centimetre for every 2 kilometres. Now it's actually 3.5 squares because it's 1, 2, 3.5. So it's 3.5 centimetres. So what have I done to the centimetre side? What have I multiplied it by? Well, I've made it 3.5 times bigger. I've scaled it up 3.5 times. We need to do 2 times 3.5. Well, 2 times 3 is 6. 2 times a half. Half of 2 is 1. 6 add 1 is 7. Well done if you got that one right. Right, next one then. If I travelled 1 square to the right from the mountains, then travelled 3 squares up, where would I end up? So that's part A. If I travelled 1 square to the right from the mountains, then travelled 3 squares up, where would I end up? And then counting those squares, how many kilometres did I travel? Answer time then. If I travelled 1 square to the right and then 3 squares up, 1, 2, 3, I would get to the treasure chest. So I've moved 4 centimetres. So here's my original ratio. I've scaled it, so I've now got 4 centimetres. I've times by 4, so times this side by 4, which would be 8. 8 kilometres. Right then, next one. Rocky Island is 40 kilometres away. So this is Sandy Island. 40 kilometres away, there is Rocky Island. What would this distance be on the map? So what distance would this be in centimetres? Pause the video, have a go. Okay then, answer time. So I'm going to show you it in this kind of horizontal way first of all, and then I'll show you the vertical way. You'll get the same answer. It's up to you which way around you do it. So here's the kind of the ratio. So it's 2 kilometres for every 1 centimetre. So they've written it the other way round this time, because this time we are dealing with the kilometres and not the centimetres. So we need to make sure that we're writing 40 kilometres in the kilometre box. So what have we done? We've times it by 20, which means we now need to times this by 20. 1 times 20 is, of course, 20. Other way we could have done this, we know there's a relationship between kilometres and centimetres that you divide by 2. So here we could divide by 2 to get 20. This is the way I would prefer to do it. That's just the way I like to set it out. I've still got my centimetres and my kilometres. I've still got 1 for every 2. That's not changed. I've then written here that I know that there's 40 kilometres. What did I do to get from 2 to 40? Well, I times by 20. What am I going to do to this side? I'm going to times by 20, so it's 20 centimetres. Last one then of this section before we move on to a different problem. So this time there's a pond 0.4 kilometres away from camp. How far would this be on the map? Pause the video, have a go. Okay, so from this time we need to work out what 0.4 kilometres is the same as in centimetres. Now, you might know what you divide 2 by to get to 0.4. It's 5. So you might know that you can divide straight away by 5 to get here. But if you don't know that, don't worry. You just need to do another step in between. So what I've done is I've used one that we actually had already worked out earlier. I know that if I can work out what 4 kilometres is, I can work out 0.4 by dividing by 10. So I've times the kilometres by 2. So I've times this side by 2 as well. So I know that 2 centimetres is equivalent to 4 kilometres on this map. Then I'm dividing 4 kilometres by 10 to get to 0.4 kilometres. So we need to divide this by 10 as well. 2 divided by 10 is 0.2. So I know that 0.2 of a centimetre is the same on this map as 0.4 kilometres. So here, again, this is the horizontal way. So here's your ratio of 2 to 1. You've divided by 5, which of course is the same, times 2 divided by 10 is the same as dividing by 5, which you're dividing it by 10, you're timesing it by 2, you are dividing by 5. Or you could do it in one jump here by just dividing by 5, which would be 0.4. So you can just divide this by 5, which is 0.2, because 2 times 5 is 10, so 0.2 times 5 is 1. Or you can look at this relationship here, where to get from 2 to 1, you divide by 2. So to get from 0.4 to here, you divide by 2, which is 0.2. Okay, loads of different ways that you can look at this. Well done. Okay, so for this question then, we've got a drawing of a car. Obviously, this isn't a life-size drawing of a car because it would be enormous and it would take up a lot of room. So we often draw scale diagrams to show them a lot smaller. But we need to make sure that we've got these measurements right, because if these measurements haven't got the right proportion to each other, we could end up with this bit here being enormous and this bit being tiny, and then our car is not going to work. So you need to make sure that you've scaled them up or down by the same amount. So on this technical drawing here then, 1 centimetre represents 30 centimetres in real life. So 1 centimetre on the drawing, which is the blue, so the blue ones, 1 centimetre represents 30 centimetres in real life. So write down your ratio. This might be a bit confusing because they're both in centimetres, so make sure you know which ones are the drawing and which one is the real life. I'm going to have a go at working out what would these all be in real life. Off we go. Right then, answer time. So here is my ratio. So there's 1 centimetre on the drawing is the same as 30 centimetres in real life. So I've written that at the top so I don't get confused. So first one, I'm going to go for the one that's 2 centimetres on the drawing. So if the drawing is 2 centimetres, I've multiplied it by 2. So I'm going to multiply the real measurement by 2, which would be 60. Next one then, I've looked at what it would be when it was 8. So if it's 8 centimetres on the drawing, I've timesed it by 8, so I need to do 30 times 8. Well, 3 times 8 is 24, so 30 times 8 is 240. That's 240 centimetres though, so what would that be in metres? Well, cent means 100th, so there's 100 centimetres in a metre. So 240 centimetres, 240 divided by 100, move it 2 places, 2.4 metres. Next one is 12 centimetres on the drawing. So I've timesed it by 12. So I have to do the real times 12, so 30 times 12. You can do this one, you can use your times tables. 3 times 12 is 36. So 30 times 12 is 360 centimetres. What would that be in metres? Well, cent means 100, so there's 100 centimetres in a metre. Divided by 100, 3.6 metres. Next one. 4.5 centimetres. So we have multiplied it by 4.5 or 4.5. So I started off by doing 3 times 4, which is 12. Then 3 times a half, so half of 3, which is 1.5. Add them together and it's 13.5. So that's 3 times 4.5. So how can I work out 30 times 4.5? Times this by 10, which would be 135 centimetres. What would that be in metres? 1.35. Really well done if you got those right. Okay then, last question for today. So we have got a scale drawing of a house. So if you become an architect or maybe like a designer or an engineer, these are the kind of plans that you will be looking at or even drawing yourselves to design houses and different buildings. So 15 centimetres on the drawing represents 5 metres in real life. So 15 centimetres on the drawing represents 5 metres in real life. So write that ratio down. When you've got that ratio in front of you, could you make that ratio easier to work with? Could you maybe simplify that ratio to make it simpler? I think you probably could. So have a go at that. And then have a go at working out what all these different measurements would be in real life. And there's also the number line at the bottom to help you as well. Hopefully you'll see the relationship between 3, 6, 9 and 12. Okay, off we go. Right then, answer time. So make sure you've got your ratio the right way round. So 15 centimetres on the drawing is 5 metres in real life. And I've put the units above it because it's not really correct to say that 15 centimetres is the same as 5 metres, because in the real world it's not. So we want to make sure that the units are kind of up here. So they're there, but so we're not kind of saying something that is wrong. It's only on this drawing, on this diagram, that is correct in this particular question. Right, let's simplify this and see if that... to be fair, there is one straight away that you know the answer to. So which one could you label straight away? Well, this one here is 15 centimetres, and 15 centimetres represents 5 metres. So this one is nice and easy. This one is 5 metres. Right, now let's simplify. So how can you simplify these? Well, they both divide by 5. So if you divide them both by 5... you'd get a simpler ratio that's easier to work with. So 3 centimetres on this drawing is equivalent to 1 metre in real life. Does that help us? Well, yes, I think so, because if you know what 3 centimetres on the drawing is, you can work out 6 centimetres on the drawing by doubling it. So 6 centimetres on the drawing is the same as 2 metres in real life. And I'm going to write this... see that? I'm going to write this onto my number line here. So 3 centimetres is the same as 1 metre. 6 centimetres is the same as 2 metres. What's 9 centimetres going to be then? Well, it's going to be 3 metres, because you've timesed this by 3, so you need to times this by 3. Next one then, what would 12 metres be? Well, this time you've timesed it by 4. Hopefully you can see we're going in the 3 times table. So 3 to 1, 6 to 2, 9 to 3, 12 to 4. And then 15 to 5. Okay, because these are all using the 3 times table. So we've worked those ones out. Now we just need to work out 4 centimetres and 5 centimetres. You can use this number line to help you here, because you can see that it's split into thirds. And that's because there is 3 centimetres to every 1 real metre in kind of real life, if you like. So that is 1 metre, but it's split into 3 centimetres. So I'm going to show you the 5 centimetre one first of all. So here we go. So we can use a number line to work it out. Or what we can say is the original ratio, I've gone back to this one, is 15 to 5. I can divide 15 by 3 to get to 5 centimetres, which is what I want to get because that's the one on the diagram. So I can do 15 divided by 3 is 5. I can't do 5 divided by 3 and get a whole number, but I can write 5 divided by 3. 5 divided by 3 would be 5 over 3, 5/3. Remember, this line means divided. And I can turn that from an improper fraction to a mixed number, which would be 1 metre and 2/3. So 5 centimetres on the map, on the drawing, represents 1 metre and 2/3 of a metre. And hopefully you can see that here, because here's 1 metre, here's 1 metre and 1/3. So this is 1 metre and 2/3. Add another third and you'd get to 6. Now, without the diagram, without the number line, working out for 4 centimetres is a little bit trickier. The number line has given us a lot of help there. However, we can still do it. So this is our ratio of drawing to real, 3 centimetres to 1. We got that by simplifying it. Now, what I'm going to do is, and this takes a little bit of thinking, a little bit of reasoning, I'm going to make it so I can work out what 1 centimetre is on the drawing. So to do this, I've divided it by 3. So I now need to divide this by 3. So now I can see that you've got 1 centimetre is equivalent to 1/3 of a metre. Okay, so for every 1 centimetre, you've got 1/3 of a metre. Then times by 4, so that you can work out what 4 centimetres would be, times this by 4. We know how to multiply 1/3 by 4. Just multiply your numerator, so it'd be 4/3, which is the same as 1 metre and 1/3. Oh, that's not very nicely written. There we go. 1 metre and 1/3 of a metre. Other way you could do this is, you already know what 12 centimetres is equal to. 12 centimetres on this diagram is equivalent to 4 metres. How do I get from 12 to 4? Divide by 3. So what am I going to do to this side? Divide by 3. 4 divided by 3 we can write as 4 over 3, which is exactly the same as 1 and 1/3 of a metre. And here, as you can see again, same as before, here's 1 metre and here's 1 metre and 1/3, which is equivalent to 4 centimetres. Right, that last bit was a bit tricky, so I hope that made sense. That's all for today. Really, really well done, and we will see you tomorrow. Bye!